You have my name here, Davide Mauri. I'm a principal product manager in the Azure SQL team. You have my mail if you have any question about what I will be showing in these days. Then you can also find me around until Saturday. Just a few words about me. As said, I'm in the Azure SQL product group. I mainly focus on developers. So if you're a developer or you have feedback from your fellow developers, just reach out to me and tell me whatever you would like to have in Azure SQL that you don't have yet, and we will try to make it happen. Of course, yeah, maybe it will take a little bit of a few time, but we are trying to make sure that Azure SQL is really the best place for developer to be when they need a database. You can also find all my social link here, my website, the blogs, Twitter, and everything. Okay. So this is the agenda, 10 interesting things. I will probably skip, or not skip, but just go quickly over a couple because we only have 50 minutes today, but you will have the slide for everything. And the slide where I will go quite quickly, you will have the link to GitHub repositories where you can find the code. You can try to do whatever I'm discussing in the slide at your own pace. So you're covered. But let's start with the first question. This is pretty easy, but if you're new, maybe just finished the university, the college, or you just started working, you may be wondering, we always talk about Azure SQL and SQL Server, and what is the difference? And maybe you are working on SQL Server locally, on your machine, you want to move to the cloud, and you are asking if Azure SQL is compatible with SQL Server. Well, let's have the clear answer. Azure SQL is SQL Server, so there is no compatibility. I go as far as to say that Azure SQL is not compatible with SQL Server because it doesn't need to be. Is SQL Server, right? So anything you do on SQL Server on premises that we support in Azure, of course, is also available on Azure. So just keep in mind that whatever you will do from the edge to Azure SQL database, so to the cloud, you can do it in all the versions of SQL Server that are available on premises or in the cloud. So this is the first important thing to know. Azure SQL is SQL Server. So if you're looking to optimize SQL Server, Azure SQL, for example, and you find a book on indexing on SQL Server, go and buy it, because it will work exactly the same in Azure SQL, right? Of course, for the infrastructure is a little bit different, because maybe you don't have to manage the infrastructure if you go with Azure SQL, but for what concerns the language and the programmability, it's exactly the same. Now, let's start with something easy, or let's continue with something easy. And I want you to take your phone right now, take your phones, and be prepared, because I want you to answer a question. So SQL is a declarative language, right? So this means that you tell the system what you want and not how to get it, because we figure out, actually, the SQL engine figures out how to get it, right? And actually, it's Query Optimizer job. And if you also want to know whose job is to build the Query Optimizer, Connor is around here, so stop in and him if you have any question on the Query Optimizer. But the Query Optimizer is the intelligent brain inside the SQL Server and Azure SQL that tries to take what you want and get it for you. Of course, when you do something, we have to take into account not only the query you're asking, but how data is distributed in the database, if index are available or not, and also resource usage, right? Because we want to give you the best query, not just one query. So, with the phone, let's start. Let me first of all show something. Let's go here, and let's set up a table, right? Very easy. Everyone can see also clearly in the back? Yes? Perfect. Super easy table, 2 columns, column A and column B. Let me insert a couple of values, and let me show you the values. So column A has value 1 and 3, and column B has value 2 and 4. Now, I am going to do something like that. Update the table, set column A equal column B, and column B equal column A. I want you to tell me, using the poll here, what do you think is going to happen? Will I have that first choice 2 times the same values 2 and 4, or 2 times the same values 1 and 3, or exactly what I believe it should happen, like have the columns switched, or just an error? Give you 1 minute, and then I will show you the result. But I'm curious to see how many will get the correct answer. And then everything is anonymous, so feel free to answer honestly, and then we'll take a look in a second. But that's interesting because once you understand that, you will understand everything else. And also you will understand how beautiful SQL is because it really removes a lot of weight and a lot of work from your shoulder. So it's really cool if you start to use it. As a developer, I always say that a developer that knows SQL is a developer with a superpower because basically you can really do stuff that otherwise would be really hard to do, or at least really annoying also to do on your code. Okay, let's go and see the result. Not of the poll, I will check it later, I'm curious, but of the query. So let's take a look at the data. I executed this already, right? So let's see what is the result. That the columns now are switched. Even if it doesn't make sense, maybe, from reading, because if you read from left to right, you could have imagine that we just duplicate the column because we say, first of all, we set column A to equal column B. So column A will have the same values column B. And then we say column B equal column A. So it will happen that we just copy the column. Well, that's not what happened. Because that line of code describes the result you want at the end. It's not a definition of what should happen. We figure out what should happen. And of course, behind the scene, we use a temporary table, and store the temporary value in a temporary table, but you don't see it. This is why Azure SQL is good, because we decide what is the best way to do what you asked for, so you can do other stuff that are more interesting. And that's super important to understand that SQL, when possible, which is unless you have specific commands and with specific constraints, is all at once. Everything happens at the same time. There is no precedence about what operation should happen here before another, right? There is no sequence. It's just the definition of what you want. Now, why it is important? Because let me take something a little bit more complex. So this is a table I have with some data, right? It's a timesheet table. And I just have a few data about reported working hours. Let's just take a look at it together. I have the ID, first name, birthday, projects, when the work on that project was reported on, the year, and also how many hours has been worked on that project for that person. Nice. Now, I have a quite complex query here. I'm using a group by, so some aggregation. I'm using a CTE, a common table expression, which is basically a subquery. And I have a where clause in here, right? And then over the result of this query, I am querying additional data. So I'm building some result set. And then on top of that result set, I'm also adding other stuff, right? I'm calculating I'm getting the previous value of the previous row, and I'm also filtering. Again, this is one query, and I just mentioned that everything here happens at the same time. Since this is true, it means that we can avoid to, first of all, execute this query, which will require a table scan, right? Or anyway, a scan of the index, if there is one, and just look for the data that has been reported by the year 2021. And then, after we found that data, if it works not all at if it would work not all at once, but just in sequence. So first of all, we should run this query, and then on the result apply this additional thing. But what actually is going to happen is that you will see in the query and the execution plan that Project Bravo, the predicate here, the query, will be actually done at the same time of the reported year. Why? Because we understand that pushing it into the inner query doesn't really change the result. So if we can do it, and this worked, so let me just show the execution plan. If it works, and we know it works, we can just, I need to zoom out a second here. And let's see, yeah, you may not be able to see here, so I'm reading it for you. Here you have something called predicate, and it shows that we are looking for the year 2021 and the Project Bravo. Actually, I can show you also by showing the execution plan. And if I go here and search for predicate, this is exactly what's happening. And as you can see, I haven't wrote that query with the end predicate. We figured out that we can do it for you, which is great because we can, maybe we can use an index on the year or on the project instead of just having to scan the table because maybe at the beginning you were searching on, just searching on the year for which we don't have indexes. And in fact, if you count, what we have to do is we just have 300 rows if we just look for the year, but if we look for the year and the project, we can optimize a little bit because we only need to read 60 rows instead of 300. It's not much for this example, but it gives you the idea that even when you have queries or views or CTs, everything happens at the same time. Of course, unless there are precedence constraints, like, of course, if here I would have filtered on the result of aggregation, well, we need to, first of all, aggregate data and then filter. But if we discover that we can just put everything together, we do that, which is pretty clever. Now, if you are not super familiar with all the CTE, subquery and view, I just wrote an article that explains when or if and when you should use a CTE versus a subquery versus a view. And this is something you will have on the GitHub repo. This is the article where you can read all the details about what a CTE is, what a view is, if they are the same or not, and if you want to also use temporary table instead. Now, having said that, let's move to other stuff. So this is just to remind you that the query, as said until now, is evaluated logically at the same point in time, which allows us to apply all the possible improvement that we have done at the query optimizer at any level to make sure that the query is as fast as possible. And as you can see over time, we added quite a lot, and we are keep adding quite a lot of improvement to the query optimizer to make sure that we can use all the possible tricks to make the query as fast as efficient as possible. Now, sometimes we have all the indexes, we try to do all the tricks, but then we can't use the index at all. Why? Well, because we can use an index only if the data we are querying hasn't been modified with respect to when it was created on the index. What do I mean with that? Let's say I create an index on last name, right? And then I search, so I write a where clause, so I search for all the people whose last name ends with something. Well, in that case, the index is pretty much useless, right? Because there is no easy way to quickly scan for the people with the last name, where the last word, the last letter of the last name is equal to something, right? So if, and this is a simple example that I think you all agree, but it shows that if we apply a transformation to a column that has been indexed, we basically disable the ability of that index to work properly on that column. Now, this implies that any transformation will result, or not any, but quite a lot of transformation will result into that. And actually, data type conversion are transformation. So sometimes when we cast the data from one type to another, we are actually disabling the index, the ability to use the index just because we are transforming one data to another. Now, let me show you what I mean by that and how subtle it can be. Let me go here. Index. I have the usual table that I used before, so nothing has changed. Still my timesheet. The only thing I'm doing right now, just for the sake of the demo, is adding a new row, right, with a specific birthday, and that's exactly what I'm going to use. Let me show which index I have here. I only have the index sustaining the primary key that I made a non-clustered, so far so good, in the sense that if I want to search for the birthday, that will not help me, right? So let me create an index on the birthday. Perfect. So create a non-clustered index on the birthday. And now I only want to find all the people, all the employee that has the birthday on April. Will that use an index? And not really. I mean, if you go and look at the execution plan, yeah, it's not using an index call, it's doing a table scan. Well, because, yeah, we created an index on the birthday, but we are only looking for the month, right? So that is not going to be helpful. So this is easy to fix. I can just rewrite my query. So instead of extracting the month from the birthday, I can just, use my human brain to come up with a conclusion that if I filter by exactly this set of data, this will actually work better. And in fact, this will actually use the index. Now you have an index seek here, right? That's perfect. Again, that's easy because it's quite obvious. But this allows me to show you that I'm using a specific format for the date, which is year, month, and day. If you use this format, you will never have issues by having a date converted using the first pair of elements as the day or as the month, depending on which regional setting you are using. So always use the ISO 8601 format, which is year, month, and date, no matter where your application will run, US, UK, Italy, France, Japan, it will always understand its year, month, and day. And this helps a lot. Because what if I do this, again, conversion? Now you probably know already, this will disable my index because I'm trying to convert the birthday, which is a date, into a string, and conversion is immediately a transformation, index is gone, just to use my preferred format to check the date. So instead of doing this, that again, it will not use the index, table scan, let's just use the regular year, month, and date format, so the index is going to be used. Again, everything is probably obvious at this point. Let me show you something less obvious. Let me create a new table right now. Let me create a timesheet test table, exactly with the same data, but the only thing I want to change is set the last name to a varchar instead of n varchar. So I'm just using a non-Unicode string for this column, right? So an ANSI string. Let me just show that let me disable this one. I don't have indexes, perfect, because I just copied, and the only thing that here, I just want to show you. Yeah, now, for some reason, I decided to set my last name as varchar. But I'm using .NET, and I'm not specifying the data type when I create my query correctly. And of course, I parameterize my query. And of course, I just say add with value. And so I let .NET figure out what is the correct data type to set the parameter. And what's going to happen is that the index is not used. Why? Well, we can simulate that in T-SQL. Let's say that I create a variable that is a varchar, and I use it. Now, I am using this ln variable to compare it against the last name. The last name is varchar. This is a varchar. Everything is working nice. And if I go and take a look at the execution plan, this is great. Oh, yeah, I haven't created the index, so it's probably better if I do. Let me set something. Yeah, here we go. Let me create the index. Let me execute the query. Nice, it's working. Perfect. Now, what happens if I change to n varchar? I'm changing the variable type, not my query, right? Which is very similar to what happens if I don't specify the data type I want to use when in .NET or Python or any other language, I specify that I have a parameter in my query. Since, for example, .NET, and as far as if I remember correctly, also the latest version of Python, all strings are Unicode, well, automatically the parameter will be set on n varchar, right? So let's see what happens. Bad. Why? Well, because the column is a varchar, and a varchar is smaller, is like a int, and the variable is an n varchar, which is a Unicode, which is a more, let's say, it's a bigger data type. So it's like I have an int and a big int. And of course, I cannot cast the bigger data type into the smaller because I would lose information, potentially. So I need to cast my column last name to n varchar by doing what? An implicit cast that you can see here. Here, I'm reading for those. Well, I can also show the XML. It's probably easier. Let's just do show query plan. Well, first of all, you have a warning. You say, I have a warning here. There is a convert is implicit. So this is not something you are doing, but as you can imagine, convert implicit is a conversion, which means, again, we are transforming the data. Index is not going to be super, super useful. So keep in mind, especially when you're using programming languages that allows you, luckily, to use parameters that are great. Make sure that you use them because they prevent SQL injection, but make sure you specify the right data type. Now, other important things, I will just go on with the demos because the slides are basically the explanation of what I'm showing. Let's go and, yep, here we go. Talk about transaction now. So you know that a transaction is an atomic unit of work. So basically, when you execute a transaction, you expect everything or to be executed and committed or roll it back, right? That's a fair assumption. So let's do some tests. Again, I'm creating my timesheet test table so I can do all the tests without breaking or having to rebuild everything from scratch every time I do a demo. And now I just want you to show that I have a row with ID 6. Perfect. Now let's do this transaction together. What do you think is going to happen? I begin the transaction, I delete my row, and then there is an error. And then I commit the transaction. Many, especially new developer, thinks that since I just said that a transaction is something that is atomic, the delete, since after that there is an error, will be undooed automatically. So let's see. OK, I executed everything, divide by 0 encountered. Let's see if there are still transactions. There should not be open transaction because I closed it, right? Perfect. Now, I deleted the row, but there was an error. So I would expect to see the row here, right? No, it's gone. Why? Because I deleted the row, there was an error, and I said, I'm fine with the error. Just commit whatever has been done so far, even if there was an error. So when you do explicit transaction, so you take care of opening a transaction and committing a transaction, you are taking also the responsibility of deciding if you have to roll back or roll forward, well, which means commit. This is completely different if I would have only executed this command alone outside the begin and commit run, right? And if instead of deleting only the row 6, I would have tried to delete all the rows, and for some error, just one row couldn't be deleted, then all the row will be rolled back, because the single command outside the begin and commit is in auto-commit mode, which means, yeah, or it works or it doesn't, we take care of everything. But the moment you say, I want to manage transaction manually by doing a begin transaction, do other stuff, then you have to decide if you want to commit or roll back. Now, you may have heard that, and I reset my original table, you may have heard that storage procedure represents a kind of a unit of work. Unit of work, it should be a transaction. So if I do everything into a storage procedure, I would expect that, again, if the storage procedure generates some error, everything is rolled back. Let's try again. So I just put the same code I used before into a storage procedure. Now, I have my data here, right? The lines, the row 6 is there. Let's execute the storage procedure. Let's execute the storage procedure. OK, that is expected. Let's check if all the transaction has been closed. Yes. Now, gone again. Because even inside the storage procedure, I am managing the transaction manually. So I must decide what to do if there is an error. Now, on 90% of the time, probably you want to simply say, I want to roll back. So why I should manage something that is so obvious? I agree with you. So what we can do is simply set exact abort on. So let's make sure that every time there is an error, everything stops and transactions are rolled back, right? I can set this into a storage procedure. So of course, the set will only have the scope within the storage procedure, not in my entire script or batch. And let me do that. Now, finally, let me, first of all, just let me show that I have the line here. Then let me execute the storage procedure. Error, fine. Transaction, all closed. Yes, now the row is there. So with the set exact abort on, I was able to automatically do what many think it's implicit, which is not, which is automatically roll back everything when the transaction errors out. If you have any reason, and I show you why you want to have one, to manually manage a transaction, you just have to use, and my recommendation is to use the try-catch block. So begin, try, which is an exception management in SQL Server, and just manage everything. And why I want to do that? Let's say I want to do something in my storage procedure, and I want to log what's happening, right? I have a complex storage procedure. I want to log all the steps I'm going through. There's a problem there. If I write something into my log table, and then something go wrong and I roll back everything, I will also roll back what I've written in my log table. Is that right? Well, there is a trick that we can use. There is only one thing that is never in a transaction, a variable. But we can have table variables. So if we create a table variable, whenever we write something into that table that is a variable, it will not be in a transaction, which means I can roll back stuff without removing it from the table variable. So that's why I'm creating a log table here, and where I have an ID and a place to store my message. I execute exactly the same code so far. Of course, here I'm committing the transaction, but what will happen is that this will generate an error. The begin try catch will catch the begin try section will catch the error and move the execution by skipping the commit run and going to the catch section. And here I'm inserting into the log table the fact that I found some error, and then I roll back. But this is into a variable which is outside my transaction, and so I can just do rollback. Everything else will be rolled back that happened within the scope of the transaction, except this. And then, for example, I can simply select from log. Now, typically, your begin catch will probably look a little bit more complex because you want to see if your transaction can be committed or not, or maybe you want to retry it. Maybe it's a deadlock. You don't want to simply undo the transaction. You may want to retry it, right? But now I just make it super simple. But now let me execute this again. Let's go and generate, test the error. Trunk count is done, yes. And so my data is here, and somewhere I should have, let me just drop everything, recreate, execute, and there should be, yeah, okay, it was scrolling down. Yeah, you see, my storage procedure should return something, and also I have a 2 result set, and here I'm showing the result of my select from @log. Of course, what I would normally do is insert the data here instead of selecting into a table of audit, for example, and I'm good. So it's very convenient also to use this technique of using temporary variable table or table variables to basically have a transaction, to have a command aside the main transaction. It's a nice trick that I recommend you to use. What else I have here for you? Oh yeah, locking, this is important. And this is an interesting difference between on-prem and Azure SQL that can be easily changed. So let's always start with my test table. And now that we know about transaction, what I'm doing is beginning a transaction, inserting some data in my test table, and then I delete something. So after that, I will have no line about project alpha in my table, and I will have one line with the secret project in my table. Then I update something about all the lines in the project Bravo, and of course, within the same transaction, I can always see what the changes I just made, right? Because I'm in the transaction. So let me do this. Let me go here, open transaction, do whatever I just said, and perfect. So we made all the changes, and we still are in a transaction because I haven't closed it, I haven't committed, I haven't rolled it back. Now, someone else, and I will go more deep into this concept of logs and everything in my session on Saturday. Now, let's say that someone comes with another connection, so another session, and tries to, nope, not this one. So let me close a little bit of this stuff here. What is gone? Oh, okay, I made a mess. No, sorry, that's here. So this one here, let me just, okay. Let me just redo this, and in the right database. Okay, thank you. Let's go here again, and I just want to open this one. Okay, thank you. Okay, now I'm on SQL Server. If I try to select from my timesheet where there is still a transaction open, well, that shouldn't happen. So that's what happened on Azure SQL. By default, you don't wait, and you can see the data that has been that existed before before my transaction. So probably I forgot to do this before. So let me just. Of course, I tested the demo once last time before doing a read committed. Yeah, here we go. Alter set. Oh no, sorry, my bad. Off. I was thinking about setting the isolation level, but that's not what I wanted to do. And that should. Okay, so I just have to start from scratch. Sorry for that, but that happens. And okay, so here we go. Again, I am in one transaction doing my insert, update, delete. That's fine. I'm still in a transaction. Let's go to another session. I'm in SQL Server. If I do that, I expect to be blocked. Because by default, SQL Server uses locking to protect me to see data that has been changed by someone else. So if I wanted to move to a higher concurrency, which costs a little bit more in terms of resources, but gives me way better performance, or at least my user will perceive better performance, which is also by default enabled in Azure, I just have to stop my transaction here, do exactly what I did before to make sure that everything was working, and then forgot to go back to the original setting, is set the read committed snapshot on to my SQL Server. If I do that, now, basically, with the rollback immediate, I'm saying, OK, stop everything you are doing, undo all the transaction, and so for that, and apply the settings I'm asking you. So that's why now I need to go back here and redo everything, because this transaction has been rolled back for me. So let me do this again. Now, again, I am in the middle of a transaction here. As you can see, this is the number of transactions open. But this time, if I query this, this will work. And I will still see alpha here, even if what is happening on the other side is that if I query for alpha, there will be none, because I deleted it. So with the versioning, anyone will still be able to see the last committed value. So everything is still completely consistent, because a transaction is not finished. Actually, the value doesn't exist until the transaction is done. So it's committed. The other transaction is committed? No. So instead of being blocked, I'm just shown the values that existed before someone else tried to change it. That's great, because it means same consistency, better concurrency, right? Now, in Azure, this setting is on by default. My suggestion is, if you are creating a new database, a new application from scratch, turn it on also for the database you are creating. It is a setting on per database level. So if you have other databases where you don't want to enable this, that's fine. But on new databases in Azure, in a SQL Server, make sure to enable it. You just get better performance, better consistency, and you are closer to what will happen on Azure. So if it works on-prem, it will also work on Azure.
What about in Azure? Can you turn it off then?
So again, sorry?
In Azure, can you turn it off?
Yes, you can. You can, or if you really want to only, the question is, can I turn that option off in Azure? So I think so. I think I never tried, but I don't see why not. So my answer is yes. 99% I'm sure you can. I'll check later, because I never tried to do it. But let's say you have one specific query where you prefer to wait instead of read the whole data. Use the read committed lock hint that allow you to basically say, OK, I prefer to wait instead of reading the whole data. So all my database will still use the same versioning methods, but that specific query will just use the lock. I don't see why we shouldn't allow it on Azure, so I would say yes, but then I will check just to be sure. And then I want to understand why you want to turn it off. So later, because otherwise, later you'll explain. Just because I still have only 5 minutes, so. OK. And now I can, of course, the transaction here is still open, so I can commit or roll back the transaction. If I commit now, everything is great. And here I can still do whatever now. Nothing is blocked right now because I committed my data. And since I committed my data, now you can see I don't have the alpha project anymore. Great. Other important stuff that I want you to know is that now we move a little bit more on the application side. don't use password. So when you create applications and the application needs to connect to Azure SQL or SQL Server, try to avoid using password and just use the new Microsoft.data.sql client that it mostly does all the work for you. So you just use that connection string. That's my favorite. There are other flavors, but that's my favorite. Active Directory Default. And automatically, the client will try all these options to make sure that your application can connect to Azure SQL or even SQL Server. So if you're working locally, it will try to use, for example, AAD or whatever it can to connect to the local SQL Server. When you deploy on Azure, if you have assigned a managed identity and you do it by just, this is an application, a web application I deployed, and my application is called DM Who I Am, which is also a GitHub repository that you can go. There is a full explanation of what I'm saying. And my application has a name, right? And the name of my application is also the name of the user I have to create in Azure SQL to allow my application to connect to Azure SQL. That's the only thing I have to do. I do create user, DM Who I Am, from external provider, and I'm done. That's it. No more password. So it's very nice because then you don't have to, rotate the password, worry about password, being leaked or whatever. And you have the full working example that you can deploy on Azure with the explanation on how to enable the managed identity and create the correct user, but it's as easy as doing a create user on the repository here. Now, as a developer, make sure that you know that Azure SQL and SQL Server has column stores. Now, column stores is a pretty cool index that we added back in 2016, if I remember correctly, where data is not stored as row, which is the typical way to store data, but as column. So it's like we save a select distinct from a single column, and we save it for each column, and that allows us to super quickly calculate aggregation, return only a specific column if you are not interested in all the other columns from a table. And the beauty of Azure SQL and SQL Server is that you can have both indexes on the same table. So let's say you have a table where you need to have both very fast query performance for what concerns aggregation and also very quick singleton lookup. You can have both a row store to quickly search, let's say, for primary key or for email, and also a column store to quickly figure out what is the most common name in an area or who has, bought the most of the product of your warehouse divided by country or region. This is how it works internally. I just want to remember that now in Azure SQL, SQL Server 2022, we also have something called the ordered column store. This is great, especially for time series queries. This is something new we just added. That's why I wanted to highlight. And let's go to the performance here. Instead of describing it to you, let me show you a typical query. This is a TPCH query on 10 gigabytes on a 2-core machine. Tiny, tiny, tiny machine. It's joining 2, 3, 4, 5, 6 tables, right? With several million columns, rows each. If I execute this query without the row store, using the row store, so not using the column store, but using the regular indexes, row stores, it takes 55 seconds, which is meh, right? But if I create the column store, it moves to 4 seconds on a 2V core, right? Which is a tiny, tiny machine. So the improvements are huge because we can just read faster. And of course, the column store is especially useful for reading really, really quickly. Now, it has an overhead when you want to write, because of course, it's complex for us to do this thing, then we do other stuff, compression and everything. So you need to find a balance. If you really want to have the super fast insert performance or update performance, probably the column store will add some overhead, so make sure. But honestly, on our LTP system, you typically have 80% read and 20% write, right? So usually having the column store is a good balance, unless again you have a specific performance requirement to write very, very fast in your data. And here there are, as mentioned, there are a lot of links on where you can find more information on this. I just want to do one last demo to make sure that you know that we have JSON support. Hopefully you know by now, but it's important for developers. So I just want to highlight that we have JSON support. Here we go. So starting from a table, that has here and here. Let me clear this out. I can just do a for JSON auto, and you can see I'm joining my project table to the timesheet, and look how the JSON look like when it goes out. It's already nested. So we also take care of shaping the JSON such we use the JSON capability to nest the data. If you don't like the scheme of the JSON we generate, you can create your own, because you have a more powerful option that is called for a JSON path, where you can exactly tell us how do you want the schema to be shaped. Maybe you want last name and first name all packed under a user object, so you can do that. Or you want to create an array, you can do that. Now, before SQL Server 2022, there were some specific JSON schema that we couldn't reproduce just using this technique. So we just released an updated version of the JSON support in SQL 2022, which is already available also in Azure SQL, where you can actually create a JSON array or a JSON object just using like a key value notation, or just passing a set of values that you want to be turned into a JSON array. This allows you to create any possible JSON schema that you have to comply with. Maybe because you are calling a REST endpoint, and by the way, remember that now you can call an external REST endpoint right from Azure SQL. There is a new storage procedure for that. But let's say you want to create you want to call a REST endpoint that expect a JSON in a certain format. It's very easy to create it right now, both using for JSON or using this new option here. Now, other thing that I really want you to know. Azure SQL and SQL Server is really multi-model, in the sense that beyond the relational model, which is the foundation on what we built everything, we also support JSON, as you saw, and even XML, if you are still using it, graph models, and geospatial data. Graph models are in particular pretty interesting, because we try to be as friendly as possible, using a syntax that is very similar to a language called Cypher, that is supported by Neo4j, which has been the lead in the graph database so far. And what you have, let's say this is the graph you want to model. What you do is just create table in the regular way, because of course, along with a graph, you also probably want to have some payload, like columns, right, or additional information. And you just mark the table, which is not a real table, but we make it look like a table, as a node or as an edge. And then you use the nodes and edges to model your graph. Now, why we wanted it to look like a table? Well, first of all, because then you can use all the tools to import, export, and manipulate tables. But secondly, because we can feed this table into the query optimizer and ask the optimizer to optimize a graph query. So the optimizer that we worked on in the last 30 years, that now is, I would say, kind of a state-of-the-art optimizer, can also optimize graph queries. For example, one new statement we introduced is called match, and this is a query you can use to find all the restaurants that my friend liked, and therefore I may like. And it's just, of course, a new syntax, match person that is a friend of a person too, that likes a certain restaurant. And I want to say, I want to find all the restaurants that I think I may be interested because my friend liked them. And that's it, that can be optimized. Everything I said before about optimizer is applicable to this. Any optimization we add into optimizer will be working on that. And guess what? Column store. You can create a graph with JSON and put a column store on it. And that's the result. You have this beautiful data set that my colleague Arvind created that contains 1 million unique songs, 1 million unique users, and this is a real one. Data, of course, it's camouflaged, but it comes from real-world scenarios, and 50 million likes. And you want to find what is the next song you should suggest me to play, based on the fact that I like that song, and my friends that has the same taste of mine also like other songs. So in real time, you need to figure out what I should listen next, right? Because you make money on that. Without a column store index, without an index, again, on a tiny 2V core machine, it will take 29 seconds to join 50 million likes, 1 million unique users, 1 million songs, which is a lot of data if you do the cross join. 29 seconds, no way. I don't wait 29 seconds to figure out what I want to use next, right? What to listen next. Row store, 22 seconds, okay, fast, but unusable. Column store on top of graph, 3 seconds on a 2V core. right? This is why I like Azure SQL so much, because everything we do, we spend, I can tell you how much time we spend, to make sure that everything works together nicely. Because we added the graph, yes, but someone want to add the JSON data to it. Okay, let's support also JSON data in graph. Well, but what about graph in analytics? Someone want to analyze the data on the graph, so let's add column store support. And that, of course, allows developers to just be able to take advantage of the feature so they can have more time to build a nice UI, build a very friendly, maybe mobile application, and just deliver a great experience. We take care of all the optimization and integration of different models. Talking about nice thing and application on the web, one objection that many developers tell me is that, yeah, but Azure SQL doesn't scale out. Hey, yes, no. Actually, it scale out. Well, we can scale out read-only workload, which, again, since OLTP is mainly 80% read and 20% write, I think we cover probably a good bunch of use cases here. But we Hyperscale, which is I wouldn't say new now because it's been out for a while, but it's a SKU, it's a flavor of Azure SQL, which, again, is not compatible with is just Azure SQL, but has been re-architected from the ground up to actually be a set of distributed services running in the cloud, right? So we can spin up a new page servers where we store your data when you use Hyperscale, not in files, in servers, or services, if you want to call it. And we also can spin up a new compute node. Now, what happens if, for example, we have the primary compute node, which is where you run your query in Hyperscale. And again, all of this is not something you should care about. I'm just telling you to explain how we do the scale out, because the only thing you see is a regular database with no difference from your local SQL server or any other SQL database, Azure SQL database. But what happens behind the scenes is that you connect to your primary node, which is where the query optimizer is, or where your query runs. It connects to a set of services that we call page server that contains your data. And of course, we read the data page, resolve your query, do whatever that you need in order to be able to get the data you need. But what if we spin more compute node, not only the primary, but more compute node that can be used either or to provide more availability or to allow you to even have other databases. What if I create immediately another database with another name, with another set of CPU and memory and whatever, and just connect those databases that I created here exactly to the same page server? Well, then we see exactly the same data, right? And the beauty is that when the primary changes some data here, well, there is no data movement to do. Any secondary immediately reads the freshly updated data, right? So with named replicas, you can have up to 30 secondary server, each one with 80 vCore for a total of 2,000 cores to crunch your data. And I can tell you can sustain pretty much any workload, right? Because also creating named replicas is pretty clever because we only spin up a compute and they consider secondary. So they cost 30% less than the primary. So instead of having maybe, 32 core on the primary, maybe evaluate to have 8 core, another pair of named replicas, each one of 8 core. Because you'll probably have more power. They are physically separate compute node, so it's more memory, more CPU for real, isolated from the primary node, where you can run all your read-only query. How can you choose where to run what? Well, there is a nice example I created on GitHub that since those are really different databases, they have different connection string. But when you connect one of those named replicas, you see exactly the same data for the primary. Even if it's a different database with a different name, a different connection string, a different set of resources. So you just basically put in your API, in your logic, in your API here, the ability to understand and in the example you have here, everything is explained, and I think also there is a video I recorded where someone is calling your API layer, and your API layer, let's say, is written in .NET or Python. A query comes in. It can be maybe, I don't know, a link query or whatever, or just a request from HTTP. You say, oh, this is a query that reads one line. Let's send it to these replicas. So you have not one connection string in your configuration file, but a pool of connection string, and you connect to one of those replicas. Good. Now someone opens the application you have built and tries to figure out what is the most common song that has been listed near him. Well, that's a complex aggregation query. You want to run it on a 16V core because you need to scan a lot of data, and so you route that query just by using the connection string to connect to this replica to the big one. Perfect. That's gone. The primary is not affected by any of the complexity running here. You're happy. You can tell me, hey, man, this is expensive. Well, yes, but you can create replicas in seconds. Because since it's just a compute node, you can spin one up easily. And let's say you use it during the peak hour, and then you want to turn it off. Yes, do it. You just stop paying, and then you can recreate again in a few seconds another one and continue to easily manage the elasticity of your workload. It's a little bit more complex than just using the serverless, but if you really need scale out and a lot of performance, that's one way to do it. And again, you have everything ready. Let me just go here to the to the survey. Just make sure that you fill out the session, and so we can have the evaluation. And in the meantime, you do that. Any question? Good. Well, come to meet me outside if you have a question. Otherwise, enjoy SQL Bits. Thank you.